Okay, we're starting the further maths portion of the mechanics today. It's a new concept here, it's called momentum, and it's defined by being mass times velocity. Now we're using standard SI units here, so mass is always going to be in kilograms. They will catch you out by putting things in tons or grams instead. And velocity will be meters per second. Again, you might have some conversion to do, maybe from kilometers per hour. Now, the unit of momentum here, we're going to measure it in kilogram meters per second. Notice that's just concatenating both of these, we're putting them next to each other. There is an alternative unit here of newtons times seconds. It comes from F equals ma. So if you think about F equals ma, like this, this thing here, the force here is measured in newtons. So if I times both sides of this by seconds, by time, we have that force times time is mass times acceleration times time. Well, this is Newton seconds on this side. On this side, we'd have kilograms, meters over seconds squared, but times seconds, which would cancel out with those. And so kilograms meters per second is the same here as Newton seconds. Right, I've got a bit of a question for you. You'll need a calculator. My question to you is, which has more momentum? So I've got two objects for you. One is a revolver bullet with a velocity of 290 meters per second. I looked up muzzle velocities, that seems about average. And it's got a mass of 40 grams. The other option here is a bowling ball with mass of 1.7 kilograms. Again, that's about average for bowling balls. And people's average striking, like successful bowl, is about 7.6 meters per second. Pause the video, which one has more momentum? Okay, right, so going through the numbers here, there's a bit of conversion to do. So for the revolver, it's 290 multiplied by 0.04. So on a calculator, I'm just going to do it off screen. 290 times 0.04, I get that it's about 11.6. And that's measured in either Newton seconds or kilograms meters per second. The other one, bowling ball, I'll do this on screen. 1.7 kilograms times 7.6 comes out as 12.92. So 12.92. And again, you can put either unit on. I'm going to put Newton seconds, it's just easier to write. So which one has more momentum? Well, the bowling ball does, but only just. They're quite close, they're about the same thing. So as something has more mass, it can have less velocity for the same momentum. Cool, right. In terms of formulas here, there's one more thing to introduce. Here it is. If I just start with this one at the top, it's just one of your Suvat equations, but I've rearranged it. It's the one which normally looks like this, V equals U plus AT. I've rearranged it for A. If I substitute it into Newton's second law, so if I put it in place of A in F equals ma, then I get this equation here. And if I times that by T, I get that Ft equals, and if I expand out this bracket, mv minus mu. Now we have a name for this. We call it the impulse. Usually we write it as I. I'm just going to write it the whole name so you've seen it once. The impulse, one way to work it out is just the force times the time. The other is you can think of it as the change in momentum. This is the final momentum. This is the original momentum, and so this is the change in them. Momentum is a vector quality, so these could be either positive or negative each, just in the same way the velocity could be positive or negative. Impulse has the same units as momentum because it's just a change in momentum. So again, we can measure it in Newton seconds, which makes sense if you think of this formula here, or you can measure it in kilograms meters per second. They will ask you about impulses, usually in the context of something hitting something and colliding. We call this the momentum, impulse momentum principle, that's it. You need to know this formula. You're going to be using it. Most of the time, we're not really going to use impulse. We're going to be just using momentum, and we'll do some of those in the next question.